Hello, my lovely friends. I hope that you all are doing good and you're taking good care of yourselves. You're staying healthy and hydrated in this lockdown period. So, as you all are aware, that our electricity session got cancelled due to some connectivity issues, some technical glitches. I could just teach till potential difference if I'm not wrong. Our Ohm's law, our resistance, everything was left. Okay, so today we'll be covering some of the concepts, probably till your resistors in series and parallel, and then heating effects of electric current and electric power will be discussed. Okay, so let's see how much we can cover. That will depend upon the length of the session. So now I'm getting started with the potential difference, as I told you. So potential difference is the work done, number one. Work done, when we are doing some work, we are applying some efforts, right, in moving a unit test charge from one point to another. Let's suppose this is my charge, so because of some efforts or because of some work, I am moving this from this point, let's say from point A till point B. Okay, so the difference between that two is known as the potential difference. I hope that is clear. It is a work done in moving a unit test charge from one point to another, and it is supervised by a battery. The battery gives the potential difference, always remember. Okay, so one conclusion that we can find out is potential difference is work done by charge. With this, we also get its SI unit, that is joules per coulomb. Work done by charge. What is work done by charge? Work done ka unit is joules, charge ka unit is coulombs. But again, to acknowledge one of our scientists, one of our physicists who have contributed, his I think name was volt. So the unit for potential difference is volt. Clear? So 1 volt is equals to 1 joules per second, and per coulomb, sorry. And you don't have VSA questions in your science exam. I hope you must have gone through the sample paper, so no need to learn the definition as such, but it is pretty simple that potential difference is 1 volt when 1 joule of work is done in bringing 1 coulomb of charge from infinity to that point. From infinity, from any point, I am bringing it to that particular point, bringing that charge, bringing the electric charge from one point to the other, right? Clear hai? Okay, so with this you can also derive the formula, that is V is equals to work done by charge, W by Q, remember that. Okay, now question for you: a 10 volt battery is supplying current to a circuit. How much energy is supplied by the battery to each coulomb of electric charge passing through it? Let's try to understand what is the question saying. 10 volt battery, so potential difference is given to me as 10 volt. लिख लिया मैंने? Okay. How much energy, here energy, work per energy में सबने पढ़ा है कि here energy refers to the work done. Okay, because work के लिए energy चाहिए ना. Without energy work हो सकता है, efforts लग सकते हैं, आपको energy चाहिए. So with here energy refers to the work done. So you need to find out the work done. Is supplied by the battery to each coulomb. Each का मतलब होता है 1. So C is given to you 1 passing through it. Now can't you find it out? It's super duper easy, people. So you can find it out. You know that V is equals to W by Q. I know this. So can I say that W is equal to V into Q, people? I can definitely say. Now just substitute the values and you'll get your answer. So I can say W is equals to 10 into 1, that is equals to 10 joules. Always remember the SI units, people make mistakes. So 10 joules, so B is our answer. Okay, people, 10 joules. You can see solution has been attached for you. Done. Okay, now talking about Ohm's law. What did this scientist Ohm give? It is basically a relationship between potential difference, current, and resistance. I'll talk about resistance also in detail, so don't worry about it. That what is Ohm's law? We read about current, we read about potential difference, we read about their their devices through which we measure the current, that is ammeter, okay, and voltmeter for the potential difference. But then what is the relationship between potential difference and current? So it talks about the relationship between potential difference as well as the current. So the relationship is that the current flowing in a circuit is directly proportional to the voltage. So what does it mean? That if the current is going to increase in any of the circuit, voltage will automatically increase. If current will decrease, voltage will also decrease. So this means that your current is directly proportional to voltage, or voltage is directly proportional to current. It means V is directly proportional to R. So children, always remember, whenever you have such thing, directly proportional symbol can be converted into equals to by adding a constant into I. Okay, this constant can be K or anything. Constant multiplied by I. This is directly proportional relation. Okay, and in my regular session, if you would have attended, I explained in depth how we choose resistance. Right now, as we are revising, you must have already known. That is IR. So in this way, we derive the formula. Here K is R resistance. Correct. So V is equals to IR. Resistance meaning which resists the flow of current, or which opposes, or you can say decreases the flow of current. That is the resistance. Resistance is the opposition of the flow of electrons. Flow of electrons, flow of charges. Flow of charges is current. Clear? And unit of resistance is ohm, since this law was given by Ohm, and in this way we got resistance. Okay, now we can reduce the current by increasing. If you want, if your father is asking that let's reduce the current in our bulb, or let's say any device, so what you can do, increase the resistance. As soon as you'll increase the resistance, your current will automatically decrease, because of the inversely proportional relationship, that they are inversely proportional. Okay, I is equals to V by R. It means I is inversely proportional to R. So if you want to increase the current, you will decrease the resistance. If you want to decrease the current, then you will increase the resistance. Correct? Okay, now talking about the factors affecting resistance, what are the factors which are going to affect my resistance? Number one is the length of the conductor. How long is the conductor? If it is like more long or longer, then your resistance will increase. Okay, the conductor is longer, resistance will increase. Now talking about cross section area of that wire or that conductor. So if that is going to increase, resistance will decrease, because it is inversely proportional to the area. So if area is more, resistance is less, because as there is more of area, more current is able to flow, so resistance won't come into picture. Okay, and last, temperature of the conductor directly related. That also I told you, high temperature, high resistance, low temperature, low resistance. Expression for resistance, here we also talk about the resistivity, people. Okay, what is the resistivity? And that is a constant over here. See, R is equals to rho L upon A. This is the formula for resistance. Very important that R is equals to, I have explained in my regular sessions about it. If you want to learn in depth, please go and check out those sessions. Okay, the link will be provided to you in the description box. Now this constant, see, what we got to know is that R is, let me change the pen. Okay, so R is directly proportional to R. R is inversely proportional to A. It means, can I say R is directly proportional to L by A? So since I have to remove this proportionality sign, I add a constant over here. Constant is rho, or resistivity. So the formula becomes rho L upon A. You need to understand that. Now time is not left to understand in depth. You need to start solving now. So just remember the. So you can see that is, if R is equals to rho L upon A, can I say that rho is equals to, wait a second, let me write over here, rho is equals to R into A by L? Can I say that? Definitely I can say. Okay, so now on the basis of resistance and resistivity, let's solve some of the numericals. Okay, the question says if 0.6 amperes current Okay, current is given to me 0.6 amperes. I just like to jot down the information, and even you should do that. It will be of great help, right? Flows through a resistor shown in figure. That is the figure. I cannot see the figure. Okay. Shown in figure. Voltage of 2 points of resistor is 12 volt. Okay, V is given to you 12 volt. What is the resistance of the resistor? Easy peasy lemon squeezy. Each and every one of you is going to tell me the answer in the chat box. Come on, you will solve by yourself. This is a revision session. This is not an explanatory session. If you're assuming it to be an explanatory session, you can say bye-bye, because here we are just revising everything. Since one shot video was incomplete, so to compensate the loss, I have brought this session to you. Okay, fine. So you will use the formula for resistance. V is equals to IR. Everything is given to us. So I will be equals to V by R. Correcto? So I will be equals to V is going to be 12 upon 0.6. And you can calculate now 120 by 6, that is 20 ohms. The 20 ohms is the answer.